Today we're looking at some extension work in the exponential and logarithm section of the higher mathematics course. We're looking at experiment and theory, and what we're going to do is we're going to try and work out the relation y has with x for some experimental data. Okay, so it's extension work. So what I've got here is I've got a process that we can follow to try to solve this type of problem. And the type of problem that we would get would be possibly a table that would appear with some values of x and y in it. And what we've been asked to do is to find the relation between y and x when the form of the equation is in y is equal to ab to the power of x. Okay, there's two forms that we actually will get in this type of question. It'll be that form there. This is the first one that I'm going to do, and then after this one's complete I'll do another one with this formula here. And what you'll be able to do is to get some more questions from your textbook or from your teacher to try to work through some of this type of work here. But I'll also give you 4 questions at the end with the answers for you to try and work through. Right, so for some experiments that we conduct, what we get is we can get x values and y values, and when we plot them, what we get is a curve of sorts. So it'll be a curve in this type of thing here. So maybe a kind of cubic or an exponential type curve. So this one here, if we just get that information, it's really quite hard to work out what the equation of that curve actually is. So what we're going to do is we're going to go through a method of working out how we get the equation of that curve using a kind of stepped method to work this out. Okay, so what we're going to do first of all is I'm going to express the given equation, so this equation here, and I'm going to express that in log form. And what I'm going to do is I'm going to take log to the base 10 of each side, and I'm going to unravel that. So try and follow me as we go along. So I'm going to start off with y is equal to abx, right? So the first thing that I'd said, we're going to take log to the base 10 of both sides. So I'm going to start with log to the base 10, y is equal to log to the base 10 abx, okay? I'm going to drop the 10 because just log y we'll know that that's on log to the base 10. Right, so what I'm going to do is I'm going to use the first law of logs, and I'm going to separate these two out here. Where they're multiplying, I'm going to separate them by an addition with logs. So I've got log y is equal to log a, and that's going to be plus log b to the power of x. I'm then going to use the third law of logs by bringing that x to the front down to here. So I've got log y is equal to log a plus x log b. Okay, so that's kind of quite close to what I'm trying to get to. I'm trying to get y is equal to mx plus c, so I can think about it as more of a straight line. So let me reorder that a bit. So what I've got is I've got log y is equal to, so for this part here I'm going to write log b first of all, and that's going to be multiplied by x, and that's plus log a. And remember, that's all to the base 10. Now what I'm going to do is I'm going to try and just compare that with y equals mx plus c. And what I have from that is that I can see that for y values I need to calculate log y. The gradient is going to be equal to log b. For the x values, well, I'm just taking the x values straight as they are. And then at the end here for c, I'm going to use log a, and I'm going to work out some values from there. So that's me just compared it there, and that's really all I've done. Okay. So the next thing that I'm going to be looking at is I'm going to try and find out which log values that I need to calculate based on this comparison that I've made here. So I don't need to work out the log of x, but I do need to work out the log of y. So I'm going to go back up to the table, and I'm going to put some values in. So what I'm going to do is I'm going to work out log to the base 10 of y. I don't need to do that for x. And all I would do in my calculator is I would just press my log button. So from there, just go for the log button there. So that's log to the base 10, and what we'll go for is 5.01. And that's going to give me an answer of 0.70 to 2 decimal places. 0.70. And just all the way along, I'll just do the same thing. So it's 0.95. So for 15.85, just the log of that would be 1.20. And finally, what we've got is we've got the log of 28.18. That's going to be equal to 1.45. Okay, so 1.45. So what I've got is I've got some more information in the table, and that's going to help me out to try to calculate the equation of this curve. Right, so what I'm going to do next is I'm going to, I hope you can see that, it's a bit on the small side, but what I'm doing is I'm going to select 2 points from the results table, and I'm going to substitute the values into a form of simultaneous equations where I can solve them and I can work out the values for A and for B. Right, so if I go back up to the table and if I look at this equation that I've got here, then from there I'm going to substitute my values in. And the two values that I'm going to choose, well, I'm going to choose this one here first of all. And what I'll do is I'll choose this one here as well. Okay. Right, so choosing this one here, so for y, I've got log y is equal to 1.45. That's going to be equal to log b. Well, I don't know anything about log b yet, so I'll put that there. For my x value, it's 4, so it's going to be multiplied by 4, and then it's plus log a. Okay, and that's the base 10. So that's my first equation, just based on the points that I've got there. Remember, I'm taking the log for this one here, and I'm taking the x value for this one here. Right, so next what I've got is, I'm going to go for this point here. So I'll start with 0.70 is equal to log b multiplied by 1 plus log b. Okay, so that's me got two equations that I can solve simultaneously. So there's number 1, there's number 2. Okay, so with the information that I've got there, with the x coordinate and with the log y, if I was to graph that, it would graph as close to a straight line. So from that straight line, I would be able to work out my gradient, and I could work out the y-intercept as well. So from there, I'm going to just solve my simultaneous equations, and from the simultaneous equations, that should work out the values that I need to do from there. Right then, let me just go back down to here and I'll rewrite the equations out. So I've got 1.45 is equal to, I'm just going to rearrange that, so that's 4 log b plus log a, equation number 1, and I've got 0.70 is equal to 1 log b plus log a. That's my equation 2. So the thing I'm going to do to eliminate here, I can eliminate the log a by just subtracting 1 from the other. So I'll take number 1 and I'll subtract 2 away from that. Okay, so that's going to leave me with 0.75. And that's going to be equal to 4 minus there, it's going to be 3 log b. Okay. So what I'll do next is I'll divide this side by 3. So I've got 0.75 divided by 3 is equal to log. I'm going to write in the base 10 there, just so that we know what we're going to do here, because we're going to have to change that to exponential form. And what I have here is 0.25 is equal to that there. So when I'm trying to work out what b is, I'm just going to change straight to exponential form, where I can just write that b is equal to the base, which is 10, and it's to the power of this value that's here, 0.25. From there, I can just work that through in my calculator. So all I'll do is I'll just use the gold button up here. So this one up here. So I'm just going for shift and that. So it gives me a 10 to the power of, and that's 0.25. That should give me an answer of 1.78. That's just to 2 decimal places. I'll just take that. Okay, so I've found out the value of b in the formula that I'm trying to work out. The only thing left now is to work out the formula, the value for a. So what I'll do is I'll substitute the value for b into and I've just put it into equation number 1. Okay, up above. Right, so let's write that out. So 1.45 is going to be equal to, so I've got 0.25 times 4, and that's plus log. And I've just written the base in as well there. I'm going to do the same with this one. So that's going to be 1.45 is equal to 1 plus log to the base 10 there. Bring that over to the other side and subtract it, so that'll leave me with 0.45 is equal to log a to the base 10. I'm going to do the same as I've done for b there, so I'll go for a is going to be equal to 10 to the power of 0.45, and then I've just got my answer coming out in the calculator, so 0.45, and we've got 2.82. Right, so what I have to do, remember, is to write the equation of that graph or the information from my experiment in this form here. The form is given in the question, so what I'm going to go for is, so we've got y is equal to ab to the power of x, so therefore the equation is y is equal to, so a value is 2.82, the b value is 1.78, so I'm going to put that in a bracket, 0.78, and that was to the power of x. So for my data that I've been given, I've worked through the kind of stepped process, and I've come up with a formula for this curve here, and the formula there is just stated here as well, so I've just got that one there. Okay, so all I would do is just follow this 6-step process, process it through, and what you'll be left with is the values that you've got for A and B, and just substitute them back into the equation, and that's your answer for this piece of work. There are different ways of doing it, by looking at the gradient, looking at the intercepts, and from that point of view you can do it that way if you like. I just like doing it by simultaneous equations. I think it's just a kind of straightforward way of working this through for any data that you're given. Looking at this log graph that I would be given here, so this here, making the straight line, this would, up this axis here, that would be log to the base 10 of y, and the values here are just the x values. So if I plotted them, then I could see what the gradient is, I could find out what the value is here, so there are different ways of doing this. I'm going to do it through simultaneous equations. One more example, and then I'll give you a couple of questions that you can either try or you can copy and have a look at a bit later. Okay then, so I'm going to follow the same process as I have with the one we did before, although the formula is going to be slightly different, and the unravelling process will tell me what I need to do based on the information that I get from there. So, different formula that we're using, so it's y is equal to ax to the power of b, and I'm not going to draw the graph for this one, I'm just going to work out the information that I need. Right, so the first thing I had to do was to show this in log form. So we're going to start with y is equal to ax to the power of b, taking the log to base 10, both sides, splitting these out by the first rule of logs, bringing the b down to the front, the third law, rearranging it into y equals mx plus c. So log y is equal to, right, so that's going to be b, and it's log x, and that's going to be plus log a. Right, so from there I'm going to write down the y is equal to mx plus c, and from there what I can see is, I can see that I need to find out the y values as log, I need to find out the x value as a log, there's my gradient, there's my y-intercept there. Okay, so I'm going to do this one the same way, just by simultaneous equations. So first thing I have to do is to work out the log to the base 10 of x and log to the base 10 of y, because in this one here, with this type of equation, I need to work out log and log as well for x and y. So I'm going to choose just 2 points. Instead of working out all the data from a table that I'd be given, I'll just work out this point here. So this is one that I'm going to use. So I'll use this one. And also, the other one I'll use this one up here at the top end of the table. So I'm going to use these two values here. So if I just put that into the calculator, what I'm going to get out is 0.477. Okay, I've got 0.6, so it's a 0.699. Then what I've got here is 0.978, and for here I've got 1.944. Okay, so that's just straight from the calculator. Okay, I don't need to work out these values here because I'm not going to use them in the calculations that I've got. Okay, so the next step was to select the points. I've got these 2 points and I'm going to try and create the equations with them. Right, so and I'm going to be using this equation here. Okay, so let me write down the first equation that I'm going to go for. Right, so let's take this one here. So I'm going to start with 1.944 is going to be equal to, so b, I don't know about b yet, okay, log x for this one will be this value that's here, so it's going to be 0.978, and that's going to be plus log a. Equation number 1. My equation number 2 based on these 2 points here, so it's going to be 0.699, it's going to be equal to b times 0.477 plus log a. So that's equation number 2. Right, so from there, what I'll do is I'll just subtract one from the other. So 1 take away 2. And what we've got here is we'll go for 1.245 is going to be equal to, subtracting these numbers here will give me 0.501. And that will be b. I've just rearranged that a bit there. Okay, so from there I can see that b is going to be equal to 1.245 all over 0.501, and in the calculator just go for 1.245, just divide that by 0.501, and what we get out is 2.485. Okay, so let's go for 2.49, and that's just two decimal places. Okay, so that's me got the value for b already for this one here. So I'm starting to get half of the results that I need. Okay, what we'll then do is from there we'll substitute. We'll substitute the b value that we've worked out, which was 2.49, and we'll put that into, let's put it just into equation number 1. So I'm going to start with equation number 1, which is 1.944 is equal to, so for b I'm putting in 2.49, I'll multiply that by the 0.978, and that's plus log 10 to the base a, let a to the base 10, and from there I'll just work things through on the calculator. So I've got 1.944 multiplying these two together, so that should give me, so 2.49 multiplied by 0.978, which gives me 2.43522, and that's plus log a base 10. Right, so what we'll do is I'll subtract that. If I take it over to this side here, so that'll give me 0.49122, and that equals log a to the base 10. Now all I'm going to do is I'm going to change that into exponential form. So exponential form, I'm going to say that a, so that's the value a, so a is going to be equal to the base, which is 10 to the power of this guy here. So it's a negative number, so put that in there. From there I can see that a is going to be equal to, so let's go for it, 10, so it's going to be negative 0.49122. That should give me an answer of, so that's where are we? So we've got 0.32, let's just go for 32, to 2 decimal places. Okay. Right then, so that's me got the values that I need for A and B. So what I'd say is that, so what we have is, so we have y is equal to a x to the power of b, and from there, for this experiment, I just substitute my values of a and b in, and that's the formula that I would follow, or the equation of a graph if I was trying to predict some information from this graph. Right, so y is going to be equal to the a value, which is 0.32, x to the power of b, and b was 2.49. And that's that complete. Right, so what I've got here is I've got a couple of questions for you to try. So, first one, okay, there's the table of values. You can freeze the video and your answer is here. Okay, that's the answer, the way it should work out. Okay. Next question, try this one here. And again, there's your answer for this graph here. Okay. Another one for you to try. So the different formula. Okay, so check and make sure the formula, unravel it, make it equal to y equals mx plus c, and simultaneous equations from there. There's your answer. There's your results. And finally, one more. Okay, so try this one here. Okay, so there's your answer there. There's your table of results, and work out your values from there. So hopefully you've found this something that you can understand. Trying to just follow a process using the simultaneous equations just seems to unravel quite easily when we're doing this work. This is extension work, and wish you all the best with this type of work here, because when this comes along the exam, it's good marks to gain. So good luck with your higher maths.